Hi, for the last couple of days you've been learning about logs and the laws of logarithms, and now we're going to use those and apply them to solving. There are three types of equations we're going to learn today. Exponential equations we're going to do again. We have done those before, but we're going to now use another method using logs to solve them. And then we're also going to learn how to solve equations with log terms in them. Okay, so the first two examples pertain to exponential equations. If you recall, that means that those are where the power contains the variable. So method number one in example one, in the past you learned that you can attempt to change bases. So on problem number one, we're going to do it first the way that you were taught. So in the past, you took the 4 base and the 2 base and you made them both be the same base. So 4 is a 2 to the second power. And I'm going to leave that. There is an x power up there. And then the 2 base, well, that already is a 2 base. So I'm going to just leave that as a 2 base. And then we have a 3x plus 1 power. Power to power, you keep the base and you multiply the powers. So 2 times x is 2x. And then the 3x plus 1 power stays. And if you can get the bases to be the same, that means we know if the bases are the same, we know the two powers are equal to each other. So we basically drop the bases and say that the power 2x must equal the power 3x plus 1. And now we can just solve for x. So the answer is -1. All right, we're going to do the exact same problem and show you another algebra technique you can use. Anytime you have exponents, the x in the exponent position, we need to bring those down. And what brings down the exponent is the logs. That's what logs are. Logs are exponents. So a more common way to do exponents as an x is to take the log of both sides. Remember, whatever you do to one side, as long as you do to the other side, you keep the equation balanced. So you're going to take the log of the 4 to the x power, and you're going to also take the log of the other side. So now we're going to use our log rules. We know that if we have a power on a term that has a log on it, we can bring the power in front. So now that's going to be x times log of 4 equals 3x plus 1 power times log of 2. Okay, you can do one of two things. The best way would be to first divide over the log of 4. All right, and that'll wipe those two terms out, and you have x equals. Now on the other side, because we have a times here, we can actually reduce these two. And we can use our calculator. Okay, so log of 2 divided by log of 4 is 0.5. Now we can distribute that in. All right, bring the x's over. And then divide out. And we get the same answer. Now, in all honesty, method number one, if at all possible, you can get the bases to be the same. I believe method 1 is a lot easier than doing method 2. But if we go on to the next problem, then you'll see what happens. Problem number 2. 8 to the x power equals 75. You can unfortunately not make these be the same base. An 8 is a 2 to the third power, but a 75 is nothing. There is no base. You could try 5, but 5 to the 1 is 5. 5 to the second is 25. And 5 to the third power is not 75, it's 125. So that one is actually a little bit harder to do to make them be the same base. So this would not be a problem you can do that with. So one thing we can do is we can take the log of both sides. So we're going to do method 2 first. So this is exactly what we did on the other problem. If we take the log of both sides, we can bring the power down. So I'm going to take the log of the 8x side and take the log of 75. So what happens now is our log rules say that we can move the x power in front. And now what I can do is I can get rid of this times by dividing out log of 8 to get x by itself. These two will cancel. And then in my calculator, I will do that because that's a little bit too hard to do in your head. Oops, sorry. Okay, and then our directions say to round to the nearest hundredths. So that will be 2.08. Now, if you look up, Google it, or look it up in a math textbook, that is the way that you're most going to commonly see how to bring down a power to solve for it when you cannot get the bases to be the same. So again, I want to stress, if you can get the bases to be the same, that's probably the easier way out. Or you can take the log of both sides. Another option that you have is to change to log form. Now this only works if only one side has the power. If you have a problem that both sides have the power, then you're going to have a problem with that because it's going to be a little bit harder. You actually can't take or change to log form. So if I can go back, sorry. So if we go back to the first problem, that you cannot change to log form because you have powers on both sides. So if you only have a power on one side, like the x power and not the other, you can take and change forms. So what's changing forms? If you recall, I can change it to log form. Now we're not taking the log of both sides, we're just changing it back to log form. Log, the base is 8, 75 is the value, and the exponent is equal to x. At this point, you can put this in your calculator. Now, the reason why this method is not as common as the other one is because not all calculators you can do a base 8. Most calculators have the regular log button, and that's a base 10. But in order to make it a base 8, you have to have the capabilities on your calculator. So on the Inspires, you have no problem. Press the log key, and you can put the 8. On the 84s, if you recall, go back to Alpha Window and go to log base, and then you can put log base 8 and then 75, and notice you get the same exact answer, 2.08. Okay, so looking back now, if you look at the gray box, this tells you again what your three methods are. You can either A, change the bases to the same base if possible. That happened on problem number 1. If you cannot change them to the same base, you have two other methods. You can either change to log form, which is what we just did here, or you can take the log of both sides, which is what you're most commonly going to see in a textbook or on Google, and taking the log of both sides, you then apply the rules to break that down. All right, so these are one type of equations you have to know. Now you also have to know how to do log equations. So example 3 and 4 are both the same type. If you notice, there is a log term on all the terms. So if there are logs on all the terms, what we want to do is we want to combine the sides together using our log rules. So first off, we know that if there's the addition of 2 logs, we can put that back together by multiplication. X times 4 is 4x. Okay, at this point, recall that if you have the same bases, I'm going to go back for a second back to problem 1. Recall that if you have the same bases right here, you can drop the bases and work with the powers. We're going to use that same idea on our problem. If you have the same logs, you can actually drop the logs and work with the insides. And at this point, now you have it really easy. Divide out the 4 and you get your answer. Okay, so again, we'll try this one more time. If you have logs on all the terms, that means we're going to simplify each side as much as possible using our laws of logarithms we learned last class. So the 2 power is going to go back up here. Now please note this is not a rule. That's already combined. It happens to be x plus 12. Okay, I can combine these 2 logs. We have a minus sign. That means I can combine them with division. The first term goes on top, the second goes on bottom. Okay, once you combine them, I have a log on both sides that match. They're both matching logs. So I can drop the logs, and I can now continue to work with the remainder of the problem and solve like normal. All right, well, if I put this over 1, I can cross multiply. And then solve like normal. Okay, now with the logs, you do have to do a simple check. You do have to make sure that the X answer will not cause the value after the log to be a negative value. You can't have a negative value after log. So if I put a 6 in place of my X here and here, I'm going to get 6 and 18. That's not a negative value for either one of those. And if I put a -4 in there, -4 makes a negative value there. So because it's going to make a negative value in the first term after the log, that is a reject. And as always, if you don't want to remember all the different ways to check each particular type of equation you've ever learned, you can always do a real check by taking the equation and putting in -4 yourself. And then you'll see that there's a problem. So you can always do it that way also. Okay, so 6 is the only one that's going to check out. All right, so logs on all the terms, condense, and then drop the logs. And then the last type, examples 5 and 6, notice we have a log on some of the terms, but we don't have it on all the terms. So if that happens, you cannot just drop the logs, because where did they go? Why did you get rid of it? So on this particular problem, we are going to still condense. So these two right there, there's a plus sign between them. So we're going to condense it by using our rules, which are to multiply. 8 times x is 8x. You are not going to drop the logs because there's a log here, but there's no log over there to drop. So how can you keep the equation balanced? On these particular problems, you're going to have to change forms. So we're going to change it back to exponent form. 2 is the base, 5 is the power, and 8x is the value. Now, once you change forms, you actually now are going back to problems 1 and 2 we just did in our notes today. So now you have a choice. You can either try to do like bases or take the log of both sides or whatever the case might be. 2 to the 5th is actually 32. So we're going to evaluate that. We no longer have a power, so there's actually, it's not an exponential equation, it's actually a normal equation. So for that one, it was pretty easy. Going on to example 6 now. Again, we only have logs on some of the terms. So we're going to try to condense this as much as possible. The 2 out here goes back up here as a power. Then these 2 right here, we have a minus sign, means we can put it back with division. You keep the log base 2, and then you divide the 2 parts. You cannot drop the log now because there's not another log on this side to drop. So we're going to change forms. 2 is the base, 3 is the power to that base, and this is the outcome. Okay, at this point, 2 to the 3rd power, I can actually evaluate. That's an 8. Okay, now you're going to just solve the resulting equation like you've learned in the past. So if I put this over 1, I can cross multiply. X squared times 1 is x squared. Then you're going to do 8 times x plus 6. Solving this like normal, we're going to distribute. Quadratic equation, I want to bring the terms over, make it equal to 0. Factor. And solve. Okay, again, I don't want you to think we always reject negative answers. We just have to make sure that going back to the original problem, I don't get a negative value after a log term in any part of the problem. So if I take 12, 12 would make both of those be positive. They're both okay. -4, though, would make this first log term have a negative value there. That is bad. So that's another reject, but again, please don't assume to reject the negatives. Some negatives will in fact work. X is 12 is the only answer. Now you can stop the video at this point. If you want to see some more problems done, I'll do 2 of each type again if you want to see. If not, shut your video right now. Okay, so I'll just do 4 problems. Problem number 1. I have an x in the variable. I have 3 options. I can either try to make the bases be the same, and if not, I can either change forms to logs or take the log of both sides. So I will show you all 3 methods on this problem so you can see the difference. I can in fact get the bases to be the same. So that would be 2 to the 2nd power for the 4, and then there's an x. and 32 is 2 base with a 5 power. Once I have the bases be the same, I can drop the base and then solve like normal. The other way you could have done this problem is to change forms. Log, the base is 4, the value you want to get is a 32. What's the x exponent that makes that happen? If you do it that way, you can go ahead and do that in your calculator. Okay, log base 4 to get 32. Basically, that's saying what exponent makes 4 become a 32, and it's 2.5. And method 3, you can take the log of both sides. And if you take the log of both sides, the power x goes in front. And then you can divide the log 4 over to break it off of the x. And then if you do this in your calculator, you have log of 32 divided by log of 4, and you still get 2.5. So those are all 3 methods to illustrate what you could do, but sometimes one method will be better than others in certain particular problems. Okay, so I'm only going to do one there. I'll do problem 4 next. Problem 4, we cannot make them all be the same base. 5 and 17, in fact, cannot be changed to any other base but 5 and 17. So unfortunately, we can't do the change of base method for problem 4. So you have a choice. You can either A, change forms, so 5 is the base, 17 is the outcome, x is your exponent out. Then you can put that in your calculator. All right, and our directions say to round to the nearest tenth. So that x answer rounded to nearest tenth is 1.8. Okay, and then the other way you could have done it again is to take the log of both sides. The power goes in front if I use my rules. Break apart the log 5 off of x by doing the opposite operation, which would be log 5, actually inverse operation. And then I can do that in my calculator. And with this, you just use the regular log key. And notice you get the same exact value. All right, now we'll try a couple of the log equations. I'll do problem 8. On problem 8, I see that I have a log on every single term. So I know for these I'm going to drop the logs, but not yet. You can only do it after you condense both sides down to one log. So on the left side here, I have a subtract, which means I can put it together with division. Okay, first term goes on top, second goes on bottom. Okay, once I get the log bases to both be the same and one of them, now I can go, okay, these log base 8s can drop, and I can just solve the resulting equation. Okay, this is a proportion, so cross multiply and solve. And make sure that 12 works. 12 does not make that negative, so we're okay. That's our only answer. All right, and we'll do one last problem. I'm gonna do the last problem. So if you go all the way back or to number 14, I believe. Yep. Okay, on this particular problem, we have logs on these two, but not that one. So we are definitely nowhere ever going to just drop the logs. We're going to go ahead and condense. Okay, so that's another division or minus sign here, so that means division. All right, so we're not going to drop the logs. We're going to change forms, which is going to get rid of the logs, but it's not just like dropping it off. So we're going to change forms. So that means we're going to have a 4 base. The 1 is the power. And then this is the outcome. Well, a 4 to the 1 power is a 4, so I'll replace that with a 4. Okay, and then I have another proportion, so I'm going to cross multiply. X squared plus 3x equals 4 times x plus 5. Now I'm going to solve this like normal. Distribute. Quadratic equation, I want to think equals 0, so bring the terms over. Factor. And then check to make sure neither answer makes a 0 for log. So 5 and negative 4. All right, if I go back up to my original problem, 5 squared plus 3 times 5, that would make 38. That's okay. And 5 plus 5 would make 10. That's okay. Negative 4, if I do negative 4 squared plus 3 times negative 4, I'm going to get 4. That's okay. And negative 4 plus 5 makes positive 1. So on this particular problem, the negative answer is actually okay. So 5 and negative 4 are both the answers.